So yesterday we have discussed about some methods that is available in throwable class to display the error message to the end user. So we have seen three methods yesterday, and today we are going to discuss what try with multiple class blocks. So we already know the purpose of try block, and we also know the purpose of catch block. Let me give you a small scenario, right? Let us say that I have a try block, right? And I have a typical catch block exception here. So the catch block is what the parameter in the catch block is defined by the class exception, right? Consider an example, like for example, if arithmetic exception is getting generated, right, this catch block will be executed. Right? For example, if a file not found exception is getting generated, this catch block will be executed, and for SQL exception, the same catch block is getting executed for all the different exceptions. These exceptions are something very different. They are not even like similar to each other. All the exceptions are different exceptions. For all these exceptions, the same catch block is getting executed. It is just like sending a request. For example, let us say that we are getting a problem with the front end application. So we usually in the real time software, a typical software employee is going to face some exceptions. It depends upon the what kind of error is going to face, whether the error is getting emerged from the front end, in the back end, or in the database, right? So let us say that the error is occurring in the front end. So to handle this error, there is a front end team. We usually have a front end team. Front end team can handle the error, right? If the error is emanating from if the error is appearing from the back end, the back end team needs to handle this error. If the error is appearing from database, the database team needs to be handling this error, right? For these three different errors, you cannot reroute this error to a particular person. In this case, I cannot reroute all the errors to the full stack developer. Right? In any typical team in the software industry, that every typical team is going to have all the resources in the sense their front end team, there will be a front end team, there will be within a team there will be front end resources, there will be back end resources, there will be database resources, and again there will also be some resources they take care of all the three things: front end, back end, database. Right? If any exception is occurring in the front end, we cannot reroute all the issues to a particular person or a particular resources. Right? So if the error is coming from front end, we cannot transfer it to the full stack developer. If the error is emanating from back end, we cannot transfer it to the full stack developer. If the error is coming from database, we cannot reroute to the same person. It is not even a good programming practice, right? So in order to as per the error that we are encountering, right, we will have to reroute the error to the specific catch block. Like, so in order to understand this further, instead of having one catch block, I know my risky code, it may generate an error from the front end, it may generate an error from the back end or from the database. I'm not sure which error I'm going to face in the runtime. I'm not sure. Right? If I'm not sure which error I'm going to get, I'm going to keep multiple catch blocks. Right? Now let me forget about the real-time analogy. Let us say that there are high chances that I may get arithmetic exception. Secondly, there are also high chances that I may get file not found exception. there are high chances that I may also get SQL exception. But I'm not sure which exception will be encountered during the runtime. Among these three exceptions, one exception will be generated, but I'm not sure which exception is that. In that case, instead of creating a single catch block to handle the code, because handling code should be an alternate code. Say that this is a handling code, right? The handling code should always be an alternate code. You cannot keep the same handling code for all these three exceptions. It's not a good programming practice. For arithmetic exception, the handling code should be different. For file not found exception, the handling code should be different. For SQL exception, the handling code should be different. Right? So exception, Java exceptions also introduce something called what? Try with multiple catch blocks. Right? Let me write that, for the better understanding, let me take another example. Now this time, let me take a timeout. So I'm going to have three multiple catch blocks. First catch block 1. So this catch block is going to handle what? If any arithmetic exception gets generated. Arithmetic exception. It is going to handle all the arithmetic exceptions. First catch block. Likewise, let me take another second catch block. This particular catch block is going to handle what? File not found exception. Right? Let me have another catch block. This is going to handle what? SQL exception. Right? I'm not sure. I'm not even sure about my risky code. My risky code may generate any one of these exceptions. I'm not sure which exception it's going to generate. For example, if I'm using my risky code is like 10 by 2, but 10 by 0. Obviously, it is going to generate arithmetic exception. We know that already, right? 10 by 0 is going to generate arithmetic exception. So this catch block will be executed. So what alternate code I'm going to specify here? The alternate code can be 10 by 2. This is my alternate code. Exception arise, it will check for the specific catch block, the matching catch block. So this is the matching catch block because the exception that is generated here is an arithmetic exception. The matching catch block is found here. So this is the alternate code that needs to get executed. It is making more sense, isn't it? Right? For example, if I say locate a file in C drive. I say locate a file in C drive, but the file is not found in the C drive. But the exception will be like file not found exception. So this is the relevant catch block that I can say. So the alternate code can be what? I need to specify the alternate code that should be relevant to the generated exception. That should be close to the generated exception. File is not found in the C drive. Please try to execute the. Please try to consider the file in the D drive. Locate the file in the D drive, or use the file in the D drive. Use the remote file in the D drive, or remote file in any drive. Relevant handling code. Exception, relevant handling code. SQL, if I am getting any SQL exception, locate SQLDB or open SQLDB. If SQLDB is not found in the runtime, or if the resources to get access to the SQLDB is is blocked, what I am trying to say, use the exception will be generated. SQL is not found in the runtime, exception will be generated. So the handling code can be relevant handling code. So if SQL database is not found, use Oracle database. This is making more sense, isn't it? For the generated exception, the generated relevant handling code can be executed. If the exception is SQL handling code right? If the exception is arithmetic exception, this handling code like that, right? This is making more sense. Just try to imagine or reproduce this thing with only single catch block. So can you specify the relevant handling code in a single catch block? If it is arithmetic exception, the handling code will be same for arithmetic exception. The same handling code will be utilized for file not found exception. The same handling code will be utilized for SQL exception. There will not be the specific alternate code. If you see, if something is happening, if this is not found, execute this. One thing is not found, execute this. If this is not found, execute the alternate thing. Execute this. Should be relevant. If DB is not found, I mean there is an exception. Execute the code with the use of open type to make use of the alternate DB. In this case, it is Oracle DB. Right? This is a good programming practice. That's why try with multiple catch blocks is used in Java to make sure that the relevant exception is getting caught, the right exception is getting caught, and the right handling code is getting executed. Right? Having the same handling code for the exceptions, for the multiple, for all the exceptions, having only one handling code is not a good programming practice, because the output is not going to be effective. In this case, we cannot produce an effective output. Me as a developer, if there is any exception generated, I need to make sure that the generated exception is routed to the right handling code, right catch block. Routing, it has to get routed to the right catch block, so that the alternate code will be specified, because here the alternate code is Open Oracle DB. Right? If I'm not specifying the right alternate code, even for the arithmetic exception also, the alternate code will be open Oracle DB. Even for file not found exception also, the alternate code can be Oracle DB. That will not make any sense, isn't it? Right? So the conclusion, in a nutshell, I can say, the conclusion is going to be very simple. So why try with multiple class blocks are used in Java? If anyone is asking you this question, the answer is going to be very simple. When the developer is not sure about what kind of exception that could be generated by risky code. By the risky code, he has an option, or he can ensure multiple catch blocks, so that the relevant alternate code will get executed. And this is the best programming practice that one should follow. Are we making sense, isn't it? Exception. This is the real-time analogy. Is very simple. For example, so this is a risky code. Just consider this as a risky code. Very risky code. But this, you know that this is a risky code. This risky code is going to generate an exception. We know that, but you are not sure what kind of exception is going to generate. There are three possibilities, right? There are three possibilities. You know that there are three possibilities, but you are not sure what exactly the exception that it is going to generate in the runtime. So in this case, the possibilities are like arithmetic exception is one possibility, and the second possibility is what? File not found. And the third possibility was SQL exception. exception. If you to recognize there are three possibilities or more than one possibility, ensure that catch blocks are created separately for all the possibilities. Ensure that you are placing multiple catch blocks to handle each and every possibilities. For arithmetic exception one catch block, ensure multiple catch blocks. Catch, catch, catch. And this risky code places this risky code inside a try block. As simple as that. Try block. Right. So let us discuss. Let us understand this with the small Java program. Meanwhile, let the SQL gets open. Right. And again, one more question is going to one more famous question. The question is like, let us say that if it is not generating, if the risky code is not generating all these three exceptions. If the risky code is not generating arithmetic exception, the risky code is not generating file not found, and risky code is not generating SQL exception. These are the assumptions. These are the these are the guessings. These are the exceptions that is anticipated. But unfortunately, what has happened? So these are the anticipations, but unfortunately, you are getting some other exception. Risky code is throwing some other exception apart by excluding these three exceptions. It is showing some other exception, unfortunately. Then what you can do? You can keep another try block with the generalized exception. So the last catch block, I mean not the try block, the catch block, the last catch block can be specified with the generalized exception. Okay, what do you mean by generalized exception? The exception hierarchy. So this is the exception hierarchy. All the exceptions are subclass of this exception class. If you notice this exception class, all the exceptions are subclass of this exception. Runtime exception. Under runtime exception, again there are many subclasses: arithmetic exception, null pointer exception, right? So if you consider this, all the exceptions are coming under the exception class. So you can place this exception class at the end of the catch, at the last catch block sequence. In this case, we have three catch blocks in this example: catch 1, catch 2, catch 3. So the last catch block can be defined with the exception class. So that is going to handle the default exception. Right? Hope it is making some sense. If these three exceptions are not for, keep on additional catch block that is going to handle the default exception. It's nothing but that is going to catch the exception which is not specified, which is not defined. Right? So let me launch this. Very simple, isn't it? Type S in the chat box if you have understood. Not sure you are getting this. Type S in the chat box if you have understood. The video is recording, that's why I'm asking you to type. Okay. Okay. Meanwhile, the Spring STS is getting opened. So this is the uses of try with multiple catch blocks. Right? And again, there is some specificity here. What is that? We need to follow some rules and regulations while declaring multiple catch blocks. There is some hierarchy that needs to be followed. What is that hierarchy? Let us understand that. Right? So let me remove this. Let me remove this code.